We're starting today with a contradiction that sits right at the heart of modern security.
Hmm.
You have these facilities, right? Research labs designed to the absolute highest biocontainment standards on Earth.
The best we can build.
And they're handling agents that, I mean, they represent the worst possible nightmare for humanity. They have biometric security, redundancy systems, layers of protection, all built to be theoretically impossible to breach.
It's the ultimate paradox of defense, isn't it? When you design for zero failure, you only need one single point of vulnerability to be exposed.
Exactly. So the question that's really driving our deep dive today is this. How does that ultimate security system fail? How does the one thing designed to remain perfectly locked down get out?
That is precisely the mission for us today, based on this stack of documents. We're not getting into the Hollywood drama of it all, but the cold, hard mechanics described in the sources.
Right.
We're going to analyze the specific pathways of potential biobreach, identify the unique and frankly terrifying dangers of a virus that was manufactured versus one that evolved in nature,
And then map out the path from there.
and then map the theoretical road, as detailed right here in these materials. That takes this whole scenario from a simple lab error to a global catastrophe.
The truly terrifying thing for me is that the scenario sources lay out is one where the escape happened despite security protocols that should have been
Infallible.
infallible. It's a story of ultimate protection being completely undermined by a minimum avoidable error.
Right.
It shifts the entire risk calculation. The facility itself becomes the primary danger.
And that shift is so critical for you, the listener, to understand. When security measures become overwhelmingly complex, the likelihood of a simple human error or a small mechanical failure, it actually goes up.
Because there's just more to manage.
There are more processes, more checks, more things that can go wrong. The sources are pretty clear that complexity doesn't always equal resilience.
Okay, let's unpack that with section 1, the breach. The source materials are quick to establish the nature of the threat here. This isn't a natural virus, collected from a cave somewhere. This is a modified, sophisticated agent, a genetically engineered bioweapon that was supposed to be permanently contained within a high protection lab, probably a biosafety level 4 facility.
And if you just look at the setup of a BSL-4 facility, you start to realize how monumental that kind of failures. I mean, we are talking about maximum containment environments.
Right.
Researchers are in these positive pressure suits, air passes through HEPA filters multiple times, and the whole building operates under negative pressure to stop any internal air from ever getting out. It is, by design, the definition of an airtight system.
So how does that theoretical fortress, how does it clash so violently with the reality of operational risk?
The documents highlight three specific, almost mundane failure pathways.
It's not a James Bond villain scenario.
Not at all. The sources focus on boring, predictable failure.
And that focus on the mundane, that's what makes this whole analysis so chilling. Because when we talk about failure in these complex systems, we often overlook the most basic element.
A human factor. Human action. The first critical failure mode detailed is the simplest possible vector for carrying a pathogen outside the sterile environment. A worker touching a contaminated surface.
A momentary lapse, just for a second. Maybe they adjust their suit, maybe they touch a monitor screen outside the sterilization chamber before realizing they missed one tiny decontamination step.
A single cognitive failure. That's all it takes. The protocol demands absolute perfection in taking gear on and off and cleaning surfaces. If a viable active pathogen is on a surface and a worker comes into contact with it,
Even a microscopic amount.
even a microscopic amount, and then they exit that final decontamination shower while still contaminated, containment has already failed. It bypasses every single expensive high-tech filter in the entire building.
And the second point you pulled out, it addresses the technology, but again, it's not some system-wide catastrophic failure. It's a localized mechanical breakdown.
It really centers on the core principle of BSL-4 containment, the pressure unit failure. These facilities rely on maintaining a strict negative pressure differential.
Think of it like a giant vacuum cleaner.
Exactly. Air is constantly being pulled into the highly contained area and then scrubbed clean before it's released. If that negative pressure system fails or malfunctions, the air differential flips,
Uh-oh.
and contaminated air can potentially be pushed out into cleaner zones or, worse, the external environment.
That's a catastrophic vulnerability. The very system that defines containment, that constant suction, is now compromised. The fail-safe becomes the point of failure.
And the sources really emphasize that this kind of mechanical failure doesn't have to be immediate or total. It could be intermittent or just localized to one small sector for a brief period. Which brings us to the third and maybe the most insidious point of failure,
The microscopic leakage.
the unseen path.
Right.
Yes. This involves the pathogen finding an undetectable way out.
Right.
It's not a door being left open, it's a faulty seal on a pipeline, a hairline fracture in a containment vessel.
Or a weakness in the bio-waste system.
A weakness that allows it to release so small, it is initially below the threshold of any of the monitoring systems. The pathogen is out and circulating before the alarms even register a breach.
And this rapid invisible spread is the crucial connection point, isn't it? Because by the time the scientists realize, hey, wait, our pressure system failed for 6 minutes last night, or we found a contaminant trace on an outer door handle.
It's too late. The initial infected individual, patient 0, is already going home on the subway.
That swiftness is the accelerant. Containment is all based on immediate identification and isolation. If that first spread is silent, the time window for any effective response has already slammed shut.
Which is terrifying.
So now that we know how it escaped through simple error, we have to focus on what escaped. This moves us right into Section 2, the threat profile. This is where the horror of this scenario really separates itself from a natural pandemic like the flu or even SARS. Why is a manufactured pathogen a fundamentally more destructive, more unknowable threat?
Because it is designed not by evolutionary necessity, but by targeted intent. Millions of years of natural selection have optimized viruses for spread, but usually not for maximum immediate lethality.
Right, because they kill off their hosts too quickly.
They burn out. But a manufactured agent can be optimized for both. It's a whole different ballgame.
Okay, so let's dive into the specific design features detailed in your sources. The first major characteristic you highlighted addresses the fact that our biological defense system, which has evolved over millennia, is suddenly just useless.
That's right. The first characteristic is its ability to create an immunological blind spot. The virus is specifically engineered to bypass or to evade natural immunity.
How does that work?
Well, our immune system recognizes threats by identifying characteristic proteins, sort of the blueprints of known viruses or pathogens that share a similar genetic ancestry.
But if this is a manufactured pathogen, those blueprints are brand new.
Precisely. If synthetic biology has been used to create entirely novel protein spikes or capsule structures, the immune system gets a blueprint it just can't read. It doesn't recognize the invader as dangerous until the infection is already deep-seated.
So our first line of defense is just gone.
Your initial crucial response, the innate immune response, is essentially useless. It gives the virus a massive head start.
And because this blueprint doesn't exist in nature, its behavior is fundamentally unknowable by any of our existing models.
That is the second critical point, unpredictable behavior. This thing operates outside the rules that we understand. Natural viruses follow observable patterns we've established over decades of researched seasonal shifts, transmission methods, symptom progression.
What with this?
An engineered virus introduces maximum uncertainty. Its parameters, its R0, its incubation period, its optimal temperature, were all set in a lab, not through natural selection.
So any initial attempts by, say, public health organizations to predict its spread or impact are probably based on flawed assumptions. They're using the wrong playbook.
Absolutely. We are, in essence, fighting a ghost. And compounding that uncertainty is the third factor, which deals with its ability to adapt and specialize. The sources suggest this agent has the potential for rapid and targeted adaptation.
Adaptation is normal for viruses, though, so how is this different?
It's the targeting part that separates it. An engineered virus might be designed with mechanisms that allow it to evolve or attack specific systems within the human body.
So instead of just a respiratory infection?
Exactly. Instead of just infecting respiratory cells, it might be programmed to preferentially attack neurological tissue, leading to sudden cognitive failure, or the circulatory system, leading to rapid organ collapse. It transforms a generalized viral attack into a highly specific systemic collapse.
And that ability to target vital systems essentially guarantees a much higher lethality rate, regardless of how contagious it is.
And tying these three factors together, perfect immunity evasion, unpredictable behavior, and targeted adaptation, is a devastating reality cited in the source material. This would likely be a virus for which there is zero existing pharmacological defense.
No known treatment.
No known treatment, no existing vaccine, and no established protocol for rapidly developing a therapeutic.
So you combine a pathogen that our bodies don't recognize, that our scientists can't predict, and that our doctors have no medicine to fight. That is the true profile of an existential threat. The moment it leaves that lab via a simple touch, The world is fighting blind against an agent specifically designed to win.
It just underscores the chilling message of the sources. We're capable of creating defenses against nature, but we are so poorly defended against our own potential technical and operational failures.
Which transitions perfectly into Section 3, the path to global spread. If the virus is this potent and containment has already failed because of a mundane human error, the immediate terrifying question becomes, well, how do you stop something so optimized once it leaves a controlled environment?
According to the sources, you probably don't.
Hmm.
Once that containment window closes, the situation shifts rapidly toward uncontrolled transmission. And this isn't just about the biology of the virus anymore, it's about the sociology and infrastructure of modern civilization.
Our own systems become the enemy.
They act as a powerful spread multiplier. We've essentially built the perfect delivery system for our own downfall.
Precisely. The structure of modern life ensures the spread is rapid and global. First, the virus itself is engineered for rapid transmission. It has to move fast before any effective public health measure can be mobilized.
But more importantly, the spread is driven by our reliance on dense connectivity.
Okay, let's talk about those multipliers. There are things we rely on every single day.
The documents identify three critical infrastructure points. First, and most obviously, air travel. What might have taken months or years to move between continents in the past now takes, 12 hours?
Right.
Air travel guarantees that a localized outbreak becomes a continental crisis almost instantaneously. You could have infected individuals in dozens of major population centers at the same time.
So you're not fighting one fire, you're fighting dozens of simultaneous fires all over the globe.
Second, crowded cities. The sheer density of metropolitan areas ensures massive initial infection rates, maximizing the speed at which the virus finds new hosts. The population density in a city like Tokyo or New York or Cairo guarantees that the early, localized growth of the virus is exponential. It's uncontainable.
And the third factor brings it all back down to everyday life. Markets and commerce hubs.
Markets, particularly those handling food or just high levels of human-to-human interaction, serve as perfect mixing and transmission environments. They act as vectors, mixing populations from all different regions and socioeconomic groups, ensuring the virus rapidly moves beyond any targeted local quarantine efforts.
So this confluence of factors, it creates what the sources define as the point of no return. Now, that's not just a dramatic phrase. What is the technical threshold they're actually talking about?
The insight here is mathematical. The sources imply that the point of no return is reached when the virus achieves a self-sustaining R0, the basic reproduction number, outside of controlled settings, and is coupled with geographical diversification.
Meaning it's spreading on its own in multiple places.
Right. For instance, if the virus establishes active, uncontrolled transmission chains across 3 separate continents via air travel before initial symptoms are even widely recognized, the possibility of physical containment it dissolves.
They're gone.
At that point, the spread is considered mathematically self-sustaining and exponential.
A moment the math flips from containment possibility to crisis management certainty. And that trajectory leads relentlessly to the outcome predicted in the sources. The worst nightmare for humanity. A global pandemic involving an engineered pathogen that outsmarted every biological and security system we designed.
It is the ultimate cautionary tale that these incredibly complex security systems are highly intolerant of simple human error. The system designed to protect us becomes the very conduit for the threat, amplified by the same technological connectivity we rely on for global function.
That synthesis is so powerful. The core takeaway from these source materials isn't really about the sophistication of the bioweapon itself. It's about how we define risk. The ultimate threat level of a manufactured biological agent is defined less by its raw lethality and more by its optimized ability to evade our known defenses, its capacity for unpredictable evolution, and the inevitable failure of human protocol.
You can design walls a mile thick, but if the threat inside is designed to bypass the fundamental rules of life itself and the security relies on a human being perfect 100% of the time, the system is fundamentally flawed.
And what truly connects the ultimate world-ending global catastrophe back to its origin, and what makes this material just so gut-wrenching to read, is the scale of that failure. The most horrifying aspect cited in the sources is that the error that started everything, the lapse that released this uncontainable weapon, could have been avoided by a single touch.
Just one touch.
A simple, avoidable operational lapse, and the world is facing an existential disaster.
It's the starkest possible illustration of complexity failing because of simplicity. We plan for these large-scale external threats, but the internal small human factor remains the most volatile variable.
So we'll leave you with this provocative thought for your own deep dive, especially as